Dear students, today I am going to explain about characterizing schedules based on serializability. Already we have seen characterizing schedules based on recoverability. Now we are going to define what are the different types of schedule: serial schedule, non-serial schedule, conflict schedule, and so on. First we are going to define what is meant by serial schedule. From the name itself, it's a serial schedule. A schedule S is called a serial schedule if for every transaction T participating in the schedule, all the operations of T are executed consecutively in the schedule without interleaving. So, suppose we are having a schedule with two transactions T1 and T2 means first either T1 will be completed completely, then the T2 will be performed, or T2 will be performed completely, then T1 will be executed. Then the schedule is called as serial schedule. Otherwise, it is called as non-serial schedule. So, based on the consistency preservation property, any serial schedule will produce a correct result. That's the reason we want to make that each and every schedule should be have a serializability property. So here we are having that four transactions. In that four transactions, four schedules. In that four schedules, schedule A and B are called as serializable schedule. Because in schedule A, transaction 1 is completed, then transaction 2 is completed. In schedule B also, transaction 1, 2 is completed first, then transaction 1 is completed. But that's why it is called as serializable schedule. But C and D will take, it is not serializable because T1 performs some operation, then T2. Then again T1 performs some operation, then again T2 will performs. Then T1 in schedule C. So it is not a serializable schedule. Same thing in schedule D. T1 performs some operation, then the T2, again the T1 performs some operation. So C and D are non-serializable schedules because C and D with interleaving operations are possible here. And problem with serial schedule is limited concurrency by prohibiting interleaving of operations, because interleaving we are prohibiting, that's the reason limited concurrency only there. That's the reason practically it is not used that much. And solution is determine which schedules are equivalent to serial schedule and allow those to occur. That is a solution for this. Then the result equivalent schedules. So they will produce the same final states of the database, maybe accidental. For example, we'll take here, there are two schedules S1 and S2. S1 performs the operation read item X and X is equal to X plus 10, then write item X. Same S2 will perform the operation read item X, X is equal to X into 1.1, write item of X. So both the schedules will take S1 and S2. Both are performing read-write operation and some updation. So here the problem, suppose that x value is equal to 100 means both the schedules S1 and S2 produces the same answer. Okay, finally the same value both are writing. So based on the result it is equivalent schedule, but we'll see the next, generally we'll see the schedule that is not equivalent. The operation performed is, it is different. Okay. So two schedules are result equivalent for the initial value x is equal to 100, but are not result equivalent in general. If we change the value, x value from 100 to some other value, it is not equivalent. Okay. So this is a thing. Then how we can check whether the schedule is serializable schedule or not means using precedence graph. So graph already we know, graph contains a set of nodes and its edges. Okay, it is there is a tree only having restrictions, graph there are no restrictions, maybe having any number of nodes, any number of edges. So we can check whether the schedule is serializable or not with the help of precedence graph. Okay, so for each transaction Ti, we are making it as a node, and so say if there is a schedule S, creates a node labeled T1 in the precedence graph. In case in S, there Tj executes read item of X. After T1 executes, then then T1 to that is Ti executes, then Ti to Tj there will be an edge. Same thing for the another operation. If Ti executes first, then Tj means Ti to Tj there is an edge. Okay, so like that it will happen. See here, we are having four graphs, precedence graphs. The first graph will take, so T1 performs first, then T2. T1 reads the value of x, then T2. Then B is T2 reads first, then T1. Then if we will take D also, T1, then T2. So if we will take A, B, C, D, A, B and D, there is no loop, or there is no loop in that thing. Okay, so that's the reason it is called as loop or cycle. So this is called as serializable schedule. So in the precedence graph is having cycle, means that is called as that is not a serializable schedule. Okay, so that is called as non-serializable schedule. Suppose we will take the C, there is T1 to T2, then T2 to T1 and so on. So there is a cycle over here. So this schedule C is not a serializable schedule. Okay, so the precedence graph, if there is no cycle, means that indicates the serializable graph, serial schedule. If there is a cycle, means that is called as not serializable schedule. Then conflict serializability means it's a one type of serializability which can be used to check whether a non-serial schedule is conflict serializable or not. So when that schedule is called as conflict serializable means if we can convert it into serial schedule after swapping its non-conflicting operations, then it is called as conflict serializable schedule. Okay, so we will interchange the swapping that operations which is conflicting, then we will convert that into serial schedule, means that is called as conflict serializable. Conflict operations are, if what is meant by conflict operations means if two operations are said to be conflict, if they satisfy the following conditions, there are three conditions are there. The first condition is both the operations should belong to different transactions, both the operations working on same data item, at least one of the operation is a write operation. Okay, then only that operation is conflict. We will see some example. So for example, similarly operations Wx of T1 and Wx of T2 are conflicting operations because both the transactions that is working on the same item x. And if we are having Rx of T1 and Rx of T2 is called as non-conflicting because there is no write operation over there. Wx of T1 and Rx of T1 are non-conflicting operations because that x, that is both the transactions are same transaction T1. Okay, it should be a different transaction means it will be conflicting, but here both the transactions are T1, transaction 1 only. Okay, so there is no conflicting. So that's all about the characterizing schedules based on serializability. There are, here we have seen what is meant by serial schedule and non-serial schedule, how to check the serializability of the schedule with the help of precedence graph. If there is precedence graph forms a cycle, means that is a non-serial schedule, otherwise it is a serial schedule. And we have seen what means mean by conflict schedule. Okay, then we have seen how to check the schedule is the operations are conflicting operations with the help of three conditions. Okay, so that's all about the characterizing schedules based on serializability.